So we're going to look at our last section for this week, which is 5.2. And this section is still on solving what we call systems of equations. We're going to spend like the next 2 academic weeks on solving systems. The first method that we learned yesterday, or the day before, was what? What's the first method that we learned to figure out the x and the y value in a system? What did we have to do? What was the whole lesson about on Monday? Yeah. Abby? And how did we solve the system on Monday? Like what was the whole process we did to find the x and the y value? And how did we get that ordered pair though? We graphed, yes. So the method that we used before was graphing. Okay? Remember, what is a system? A system is when we're solving at least 2 equations. You can solve for more. Sometimes you have 3 or 4. In this class, we only do 2. But the point is, you need to give me 2 answers, an x and a y. And you guys already have that written, I think, on your guided notes from Monday, so you don't have to write that down again. But it's when you're solving 2 or more, in this class 2, and you have to write 2 answers. Usually we use x and y, but if you're doing a word problem and you want to use different letters, like the basketballs and footballs, and B and F make more sense to you, then use B and F. But we'll most of the time use x and y. So we talked about the method we did on Monday. It wasn't yesterday, but it was Monday. Why is graphing not always an easy approach to use? What's some things that can be difficult about trying to graph 2 lines and see where they cross? Yeah?
The numbers are really big.
Yeah, exactly. If you have really big numbers, like numbers in the hundreds or thousands, unless you scale your axis or something, it's going to be really hard to see where they cross. What else is hard with graphing? Yeah?
If the numbers are decimals.
Yeah, if the number's a decimal, you're never going to be able to get an exact answer. I mean, how are you going to tell if 2 lines cross at like 1.6? You're not. You can't. I mean, if you use a graphing calculator and you do it, you can. But just using pen and paper, it's not difficult. I mean, it's not easy. So the other thing is you need to have a ruler and you need to have a piece of graph paper to make it work. But you guys get the other ones. You can get decimal answers and your numbers can be really big so they can go off the graph. So what we want to look at is a method for solving systems that doesn't rely on graphing. Okay. Graphing is okay, but it's not the best method for bigger numbers. So we're going to look at a method called substitution. And there's going to be a couple different situations that can happen. We're going to look at one today, and then we'll do the other one tomorrow. All right, so on your guided notes at the very top, you have something that says situation number 1. And this is what we're going to write down. Situation number 1 is the easiest situation. It's where we already have a letter by itself. Notice it says X or Y. It does not have to be the Y by itself. It could be the X. And that's okay. The point is you need to have a letter by itself on one side. In situation 1, I guarantee you will. You are not going to have to deal with what happens if you don't have a letter by itself. That'll probably be tomorrow. But in situation 1, you are already going to have the X or Y by itself on the left side of the equal sign. And you're going to be given two equations. So maybe the x or the y will be by itself in both of them. Kind of like, I'm just going to go back to the warm-up question for a second. This is an example in the warm-up where there's a variable by itself in both of them. The y is by itself in the left on the black one, and it's by itself on the left in the red one. But you have to have it by itself in at least one, but maybe both. And what we'll do is we're going to do an example as we write the steps. So we'll write a step, and then we'll do that step in a problem so you can see how it works. So step one, you're going to look at your problem, and you're going to find the equation that has the variable by itself. And you're going to put parentheses around the information after the equal sign. Okay, this step isn't really a math step. It's more of just kind of like to organize our thoughts and what we're getting ready to do. So you're going to find the equation that has the variable alone, and you're going to put parentheses around the information after the equal sign. So now I'll give you guys a problem and I'll show you how you do step one. No, there's not a ton of space for writing it down, but hopefully you have enough space on those two lines. We're on the other side. Okay, so it says find the equation that has the variable by itself. Can anyone tell me, looking at the top one and the bottom one, which equation has the letter by itself on the left side? Top one or the bottom one? The bottom. So it says put parentheses around the information that comes after the equal sign. So all you're going to do in this step is that. That's step one. Put parentheses around the information that comes after the equal sign. And the reason we're putting parentheses is because it tells you what to focus on. Okay? This is what we're going to focus on for step two, the stuff that's in the parentheses. But now I can tell you what to refer to because there's parentheses around it. Does everybody have step one? Okay, step two. We're going to put some more parentheses. Where are we going to put them this time? We're going to put parentheses around the variable in the other equation. We're going to put parentheses around the variable in the other equation. We're just going to stop there and do that stuff. So can someone tell me, in the bottom equation, what letter was by itself? Yeah? Y. So the isolated variable in our problem was a y. It might not always be a y, it might be the x. In this problem, it's the y. So you know what, I'm not even going to write that. So put parentheses around the y in the other equation. Just like that. Any question on that step? Putting parentheses around the variable that was by itself in the other equation. Okay, now we're going to do what this whole method is about. Now we're going to substitute. What are we going to substitute? Oh, let's keep reading. It says to plug in the information that already had parentheses around it for the letter up above. So in other words, all of this stuff is going to go right there. Why is it going to go there? Because this bottom equation says y equals, and it gives us a formula. Y is 3x plus 7. Since we know y equals 3x plus 7, we're going to change the y in the top equation to 3x plus 7, because that's what it says y equals. So take the information they give you, y equals 3x plus 7, and fill the 3x plus 7 in the top equation for y. All right, so let's do that. So we got this, and we're going to take that information, and it's going to go right there. Everything else in that top equation is going to stay the same. Just change y to what the bottom formula tells you the y equals. So we've got 6x plus, and what am I going to put after the plus sign instead of the y? Yep. We're going to put in 3x plus 5. So this information is taking the place of the y. It gets filled in. Now, look at the equation that we have. We started with two equations. Each equation had an x and a y in it. It had two different letters. How many different letters are in this equation now? How many different letters are in that equation in red? There's no letters at all in it? One. Yeah, there's only one letter now. And that's what should always happen after step 2. You should end up with an equation that only has one type of letter. It might be written a couple times, but there is only one type of letter in that second equation, and it is an x. Now we're going to be able to solve that equation by combining like terms. So that's step 2. So solve the equation that we just made. And again, what you should look for is it should only have one, I'm just going to put one type of letter. That letter may be written more than once, but you only have one type of letter. Okay, so how do you solve that equation? Well, two things usually are going to come up. You might have to combine like terms, and you may have to use the distributive property. This particular problem does not have distributive property. So we practice that in the warm-up, but we don't need to use it here. Now we're going to solve the equation that we just made in step 2. And I left a little bit more space under step 3 because you got to do some work. So you might need a few lines to do this problem. So can anybody tell me what would be my first step to solve that equation? Let's see, Abby? The 6x and the 3x. Yep, we're going to combine like terms. And what do you get when you combine those together? 9x, yes. Now we can't combine it with the 5 because the 5 doesn't have an x. So 6x plus 3x is 9x. Everything else stays the same. Okay. What would be my next step? Yeah? Yep. Good. We're going to subtract the 5. So when we do that, that gets rid of the positive 5. And what's negative 22 minus 5? Yep.
Negative 27.
Good. Negative 27. And now I'm down to my last step to get x by itself. Yep.
Divide 9 on both sides.
Good. Divide 9 on both sides. That's gone. And we have negative 27 divided by 9. Just be careful because it's a negative divided by a positive. Yep. Good. It's negative 3. So there is the answer for x. But what other letter was in this problem? Think back to like step 1. There was another letter in this problem when we started. Yeah? We had Y. Well, when you're solving for a system, you can't just find one letter. You need to find both. So if you found that, I'd say, okay, you get half credit because you have X. But now we need to figure out Y. Once you find X, though, Y is easier. Okay, so let's see how we would find Y. So now, you're going to take the number that you just got. So we're going to take this negative 3, and we're going to do something with it. You're going to take the negative 3, and you're going to plug that number in to the other equation. We're going to scroll back up and see what that equation is. Now, I can't say at this step if you're going to be finding X or you're going to be finding Y. In this problem, we're now finding Y because we did X first. You might not always do X first. You might do Y first. Okay, so it depends on the problem. But the point is, once you get one of the letters, now find Y. Now, how many equations did they give me originally? How many did I start with? Yeah? 2. I started with 2. You can take this number And you can fill it back into either one of them to get the next answer. The key is we want to pick the easier one. You won't be wrong no matter which one you pick. But try to pick the one that looks easier. So we have X. What letter do we need to find now? Yep. We need to find Y. So let's go back up. Let's look at the two equations, and let's see which one looks easier. Okay, we're going to be filling a -3 in. But which equation do you want to fill the -3 in? Do you want to fill it into the top one? Or do you want to fill the -3 into the bottom? If you do it correctly, you will be right no matter which one you pick. Let's try to pick the simpler one. Yeah? The top one. All right, why do you think the top one is simpler?
Because when you have to do the negatives and stuff, they will end up being positive.
Okay, so Aiden thinks the top one. Does anyone else have any other thoughts about which one? Because remember what, yeah. Exactly, because the bottom one already has y by itself. That's the next step. Solve for y. If you pick the top one, you're not wrong. You can do it. But the y isn't by itself, so it's going to be more work. If you pick the bottom one, the y is already alone. That makes it a lot easier. So I would pick the bottom one, and the numbers are smaller. You don't have a number as big as -22 in the bottom. So let's copy down the bottom. Y equals 3x plus 7. Now, what number are we going to fill in for x in that equation? Yeah? -3. This -3 is going to go right there. So we get y equals 3. Leave room to fill something in. And I want you to fill in -3. How about Joe? What's 3 times -3? Well, think of what's 3 times 3, and then we're just going to make it negative. Nine, and then -9. Yep. Okay, so we got -9 plus 7. And what is -9 plus 7? Yep. -2. And there you go. So what we just did right there, that took the place of what I taught you just 2 days ago. We didn't have to graph anything to solve this. If you did graph and you had the 2 lines drawn, they would cross at the point -3, comma, -2. So this would not be a bad one to do with graphing because they do cross at a nice spot. It's not a risk. Okay, so that's step 4. And then step 5 is, well, we can just write our answer. You can write it a couple different ways. On Edge Elastic, if I set it up as 2 different boxes, you'd put a -3 in the X box. And then you'd put a -2 in the Y box. Or, if you want to write the answer the way we learned on Monday, you could write it as a coordinate. A coordinate is how you represent an X and a Y together. And that's substitution. And the problems we look at today are going to all be pretty much like that. Yes, it takes a little bit of getting used to, just to kind of, learn the steps. But once you get the steps, it is better than graphing. Yeah, yeah. So let's try another one and kind of go through the problem and keep these steps handy, because you'll have them because the problem is on the same page as your steps. So we're still on the bottom of the first page. Example 1. Okay, so solve the system. All right, so let's go through the steps. Can somebody tell me what does step 1 say to do? Yep. Find the equation that has a variable that's isolated on the left-hand side. Is there an equation that's isolated? Is there an equation with a variable by itself here? The top one. Yes, I agree. The top equation has a variable by itself. Okay, so we did that. Can you keep reading step 1 for me?
Okay. Fully sign, parentheses around the information.
Put parentheses around the information after the equal sign. Okay. And is there anything else in step 1? I think that was it. Okay, that was it. So we found the equation with a variable by itself, and we put parentheses around the stuff after the equal sign. Okay. Step 2. What does step 2 say? Yep.
Put parentheses from the isolated variable in the other equation and plug it into the other equation.
Yes, so put parentheses around the isolated variable in the other equation. Why is the isolated a variable? This is the other equation. So we're going to put parentheses around the y in the other equation. And can you read that last step again?
Plug it in the other equation.
All right, what are we going to plug into the other equation? Right, the negative 2x minus 9 is going to get plugged into the other equation. Where is it going to get plugged in? For y. This goes there. So the top equation says y equals all this stuff. So change the y in this equation to all that stuff. So we're going to now write the bottom equation as 6x minus 5. Remember, you always keep your parentheses there. That's why we put them in. And instead of putting a y right after the negative 5, what am I going to put in there? Inside those parentheses? Yeah?
Negative 2x minus 9.
Good. Negative 2x minus 9. Now, this one has a property in it that we talked about in the warm-up. What do we have to do first here that we practiced in the warm-up? Yeah? Not yet. We have to distribute. So the first thing we have to do here is distribute. Can anyone tell me, what am I distributing? Yeah? Right. You got to be careful. You're distributing this. The sign to the left always goes with the number. So that's what we need to do. That's not going to have any effect on the 6x. So we'll just leave that. And Anaya, when I do negative 5 times negative 2x, what does that give me? 10x. Good. And Abby, when I do negative 5 times negative 9, what does that give me? Can you help her out? What is that going to give us? -5 times -9. Yeah.
Oh, 45.
45. Yeah.
I thought you said 6.
Oh, okay. Yeah, so -5 times -9 gives me 45. The -19 does not change. Now we can do what Michael said, which was combine like terms. What are my like terms there? Yeah.
6x and 10x.
And what do you get if you combine 6x and 10x?
16.
16x. Okay, so it's looking better. It's getting a little bit smaller each time. It's getting simpler. What would be my next step? We might need a calculator for this, but what would we do next? Yep.
Subtract 45.
Yep. Subtract 45 on both sides. So I have 16x. I'm going to use my calculator. -19. Let's go. -19 minus 45 is -64. Okay. And now I'm down to my last step. What is my last step to get x by itself?
Divide 16 on both sides.
Perfect. Divide both sides by 16. So -64 divided by 16 is -4. And there's the answer for x. Okay, are we done? We have an answer. So are we all done? No, what do we still have to do?
Yes.
Right, we still have to find y. So that's the next step. So step 4 says to take this number and fill it back into one of these two. You can't make a mistake with which one you pick here. Both of them will work, but one of them is easier. Which equation do you think is easier to plug x into so we can find y? Yeah? The top one. Yep. So let me go like this. We're going to take this number and we're going to fill it back into the top one. If you want to do the bottom one, you can, but I think it's going to be harder. So let's see what happens with the top one. I have y equals -2. And then right after the -2 was the x, but don't write x anymore. Put -4. Okay. -2 times -4. Yep. That's 8. And it says y equals 8 minus 9, which gives me -1. And there you go. So there's your answer for x, and there's your answer for y. You don't necessarily have to put them like right next to each other like that. As long as you put a box around it so I can see you got x and you got y, that's fine. But that's pretty much all the work you have to do for substitution. That's an entire substitution problem right there. So you can see the first step to get x, that's more work. Okay, we had like 1, 2, 3, 4, 5, I don't know, 6 or 7 lines. But to get y, we only had 3. So once you get your first answer, the second answer is easier. Yeah. Any question on 1b? Okay, let's see, we'll try 1c and d. I don't know if we'll do both. Let's see. So 1c, 1d, they're both kind of the same thing. All right, let's do 1c. So step 1 is to find an equation that has the letter by itself. Is there an equation here that has the letter by itself on that side? Yeah. Yeah, which one? Top one? Anyone else think anything different? Yeah? They both have. So what that means here is you have a choice. I would just go with the top. If you have a choice because they both are by themselves, then just use the top one. So the first step is always to put parentheses around the information after the equal sign in the equation where the letter is by itself. They're both by themselves, so just use the top one. And where else do we put parentheses? Yeah? Around what variable in the other equation? For y. Right? You always put your parentheses around the variable that was isolated in the other equation. So the isolated variable was y, so we put parentheses around the y. The isolated variable was a y, so we put parentheses around the y. Okay, so there's your first step. And now we've got to fill something into the second equation. Who can tell me what we're going to fill into the second equation? Yeah? Yep, what's in the parentheses?
X plus 5.
And what letter is the x plus 5 going to get filled in for?
Y.
The y. Because it tells you y equals all that stuff. So change the y in this problem to all the stuff that it tells you it equals. So this goes right there. Everything on the right-hand side is going to stay the same. But you're going to change the y in the bottom equation to what it tells you it equals in the top equation. X plus 5. And now, solve for x, just like we always do. Okay, I want to get all my x's on one side, and it would be nice if I could keep the x's positive. So what could I do on both sides to get all the x's on one side and try to keep them positive? Yep.
Subtract both x's by 1x.
Yeah, subtract both sides by x. Okay, so subtract the x on both sides. That's gone. Brady, if I do that, what's on the left?
What's on the left? It would be 5.
And on the right, 5x minus 1x.
4x.
Gives me 4x. Okay, so that's good. We got all the x's on one side. What would I do next to continue getting x by itself? Yeah.
Subtract 12 on each side.
Very good. Subtract 12 from both sides. So I need to do 5 minus 12. Let's see. What's 5 minus 12? Yeah. -7 equals 4x. And what would be my last step? Yeah. Divide by 4. So we're going to get x equals, and this time, I guess if you wanted to do it out, you could. -7 divided by 4. That's -1.75. Now there's one that you would never be able to tell that by graphing by hand. How would you tell that you're at 1.75 or -1.75? That's 2%. Okay, so now we've got x. Once you find the x, think about what I still need to find. Okay, so we've got the x. What do we still need to find? Yeah, y. We still need to find y. And does it matter which equation you take this number and plug it back into? Do you think, Jacinta?
No.
No, it doesn't matter, but try to pick the one that you think is the easiest. Which equation do you think is the easiest to fill that number back into? Yeah?
The first one.
I would say the first one because the numbers are a lot smaller. So take this negative 1.75 and you're going to fill it back in for x right there. So you're going to have y equals, now don't put x, put negative 1.75. And we'll use our calculator. Negative 1.75 plus 5. Again, another number that it would not have been very easy to tell by graphing because it's a decimal. But doing it with substitution, it wasn't really any harder than when it wasn't a decimal. We just use the calculator. Any question on that? All right, so that's substitution. So what we can do is tomorrow we'll review the problem. I'll do a warm-up. Maybe we'll do example 1B as a warm-up tomorrow. And then we'll finish up substitution. Okay, so homework tonight is worksheet online 5.2 part 1. I think there is a word problem, but if you get stuck on it, we'll go over it at the beginning of class tomorrow.